This is Daryl with Cisco Hands-On Training, episode 19. Today we're going to talk about OSPF totally stub areas and not-so-stubby areas. It's the 29th of September 2007, and one thing, I'd request if you like this webcast or if you like this video podcast and you want to support it, the best way you can support it is by linking to my website. That'll improve my Google page rank. It'll show other people, help show other people where the website is, which since it's useful to them, it might be, since it's useful to you, it might be useful to them. So I'd appreciate the free link, and that's a free way to support me. Let's get into it. Here is our diagram. It is the same diagram as last time. In our network, we have 3 routers. We have a RIP version 2 area. We have a RIP version 2 domain with in the purple areas. We have OSPF divided into 2 areas. The black area is area 0, and the red-orange area is area 172.16.6.0, and it's currently a stubby area. Let's go ahead and look at the route table in the OSPF database on the bottom router to remind ourselves what the effect of the stub area is. So here is the route table on the bottom router, and you can see the bottom router has 3 directly connected routes. It has 2 OSPF inter-area routes, which are OSPF summaries coming from area 0, and then we also have our RIP route, which we have a RIP route for a /32, and then we have, because we're a stub area, we don't have any external LSAs. We don't have any external autonomous system boundary router LSAs. We just have a default route pointing at the area border router. Let's look at our database. Show IP OSPF database. In our OSPF database, we have 2 router LSAs because we have 2 routers inside this area. And then we have 3 summary LSAs for the 3 subnets that we're learning from area 0. And you notice we don't have any type 4 autonomous system boundary router LSAs or any type 5 external LSAs. Let's go ahead and today the first thing we want to learn about today is the totally stubby area. The reason to do the stub is it improves the scalability of your OSPF domain. In particular, we don't have our we have less LSAs and less route entries than before, thanks to our stub area, but we only got rid of the external LSAs. We didn't get rid of the summary LSAs from the other areas. And if you have many areas in your OSPF domain, or if you have a large OSPF domain, you could have hundreds or even thousands of routes that need to be advertised from other areas, and those thousands of as a result, you have thousands of summary LSAs, and that can be a substantial impact to the router. And in this environment, you don't really need to know how to get to 172.16.2 versus 172.16.1. You just need to know to get to the area border router, because this is a relatively simple topology. So in a totally stubby area, you actually suppress the type, in addition to suppressing the type 4 and type 5 LSAs, you also suppress the type 3 LSAs. And all you have is your routing LSAs for your own area, plus you have a default route which points you back to the area border router. And that's it. So let's go ahead and configure that. So conf t router OSPF 1 area 172.16.6.0 stub. And the way you configure a totally stub area is the additional keyword after stub, no-summary. No-summary. And I configure that. Show IP OSPF neighbor. And my OSPF neighbor is now in the EX start category, and it's back to the full category, which is, so my OSPF neighbor is up. Let's look at my OSPF database. And the OSPF database appears not to have changed. I I have refreshed my router LSAs because my neighbors reset. Let's go ahead and look at the top router and configure the same thing. You know, I learned things doing these podcasts. In this case, I just configured this area as a stub no summary, and I was expecting the OSPF neighbor to go down because the flags would be different. But if I do show IP OSPF neighbor, you can see my neighbor is still up, even though the top router is not yet configured as a totally stubby area. It's just configured as a stub, and the bottom router is configured as a stub no summary. So I did some research in the book, and you know something, you only need to configure you only need to configure as a totally stubby area on the area border router. So let's go ahead and back out of that recent change. Conf-t router OSPF1 net area 172.16.6.0 stub. And you note I'm not using the no summary keyword there. Let me do a show run to verify that it took that config. And it still thinks stub no summary. So I think what I need to do is router OSPF1 area 172. No area 172.16.6.0 stub. It won't let me type in no summary here, so let me type in stub no dash summary. And this feels dangerous to me because I'm worried that it might cause me to lose the no summary command and the stub command. I don't see a way to get rid of the no summary without also getting rid of the stub here. So let's see what effect this has. Show run. Okay, and the command no area 170.16.6.0 stub no summary, it just got rid of the no summary. It still left the stub. So my network's still up. Show IP OSPF neighbor. Show IP OSPF neighbor detail. And my neighbor is up. Let me see if I can do a show clock. Show log. You can see I haven't set my clock in a while. Okay, so I've configured it back to stub. So my bottom router is back to the original config, which is the area is a stub, but it's not no summary, because I only need to configure no summary on the top router, on the area border routers. So let me go ahead and do that. Here I am on the top router. Router OSPF1 conf-t, router OSPF1 area 172.16.6.0 stub no dash summary. Okay. And you can see my neighbor is down, adjacency forced to reset. So we saw that before when we configured it as a stub router. A stub no summary router. It can still form a neighbor relationship even though the router on the other side is not a totally stubby router, it's just a stubby router. But it still forces the neighbor to reset. So let's go ahead and look at the OSPF database. Show IP OSPF database. And you can see now in the totally stubby area, I'm generating a default summary network link state. So this is an OSPF type 3 LSA, an OSPF type 3 summary, and I'm generating a default. I am the advertising router, and that is the only summary that I'm generating. I'm not generating any summaries for the subnets in area 0 and shared across. And I also still, because I'm part of area 0, I still have the type 5 autonomous system external link states on this router. If you notice, I do not have any type 4 LSAs because I am an area border router, and so I would originate them into a non-stubby area because Type 4 Autonomous System Boundary Router LSAs are originated by the area border routers. Let's go back to the bottom router and take a look at the effect of our making this router a stub no summary. Here I am on the bottom router, show IP OSPF database. And you can see in the OSPF database, I'm down to 3 LSAs. I have the 2 router LSAs for area 172.16.6.0, and then I have the default 0.0.0.0 default summary LSA, which is being originated from the top router, which is a totally stubby router. The configuration is stub no summary for this area. Let's look at the route table, show IP route. And you can see I have my 3 connected routes. I now have 2 RIP routes, but the only inter-area OSPF route is the default. So that shows that the stub no summary, which is totally stubby, is working as we anticipate. We don't get any specific routes from area 0. We just get the default route, which is introduced by the area border router. Now let's say that's stub no summary. Let's say that on the bottom router I want to redistribute from RIP into OSPF. Let's go ahead and try it and see what happens. Conf T, router OSPF1, redistribute, RIP, subnets, metric type, metric dash type 1. And it came out a warning. Router is currently an autonomous system boundary router while having only one area, which is a stub area. So it's warned me that there's something wrong. Let's go ahead and look at my OSPF database. And you can see there's no change in the OSPF database. I'm not redistributing anything into OSPF here. There's no external LSAs. And you know that makes sense because in a stub area, you ignore external LSAs. You ignore Type 4 and Type 5 LSAs. Like we saw that at last episode when we configured our area to a stub area, we still had some Type 4 and Type 5 LSAs that had not timed out, but even though they were still in our OSPF database, we were ignoring them and not processing them in the route table. So even if we redistributed the RIP routes into a Type 5 external LSA, the other routers in the stubby area would ignore it. Because it's a stubby area, you're not supposed to see any Type 5 LSAs. So this is a limitation on stub OSPF areas. A stub OSPF area ignores external routes, so you can't redistribute from another routing protocol into a stubby area. And that can be really annoying because not only is RIP another routing protocol, but for the purposes, but even if you had a static route and you wanted to redistribute the static route into OSPF, you can't do that into a stubby area. And static routes are things that you want to redistribute into your network. In lots of places, particularly the edge, in like a leaf node, like in a connection to a lab, and that's exactly where you might want to put a stubby area. So they had to change the OSPF protocol to fix that. They had to add a new type of LSA. And let's go ahead and take a look. Let's conf T router OSPF1 area 172.16.6.0. Let's see what options we have. And we have authentication, which we haven't talked about. We have the default cost, which we have not talked about. We have the stub. We're not going to talk about virtual link yet. We haven't talked about the range yet. There's one other thing that's interesting. NSSA. That is a not-so-stubby area. So what we want is we want an area with a simplified routing table where we don't have to put all of our external routes and summary routes into it, but we still want to redistribute a few routes into it. So we need a route that's stubby, but not quite so stubby. And so that's where they came up with this crazy thing, which is called the not-so-stubby area. So let's make area 172.16.6.0 NSSA. So, and it says area is configured as a stub area already. So I don't know if that command took. Let's take a look. It seems to be indicating that it did not take. Yes, it did not take. Conf T, router OSPF1, no area 172.16.6.0 stub, area 172.16.6.0 NSSA. Show IP OSPF neighbor. Show IP OSPF neighbor. And my neighbor is down, and it's still down, and it's still down, and it's still down, and it's not coming up. Why is it not coming up? Let's see if there's anything in the show log. Nothing in the show log. Conf T router OSPF1 neighbor. Nope. Log. I'm looking for a command like log adjacency changes or something like that. This is a pretty old version of iOS, so we're not getting all the logging we want. Bottom line is we configured a not-so-stubby area on this router, on the bottom router, and we are not neighbors with the top router. And again, that makes sense because the top router is a stub router, and the bottom router is a not-so-stubby router. And the OSPF in an area, you must have the same type, whether it's stubby or not so stubby in an area. So otherwise, you don't form a native relationship. So this is another example of an impacting network change. We had a stubby area, and then we configured the bottom router as a not so stubby area, and it can't form a neighbor relationship until the other routers in the area are also not so stubby areas. So let's go ahead to the top router and fix that. Here I am on the top router. Conf T router OSPF1 area 172.16.6.0 NSSA. Oh, same thing here. So no area 172.16.6.0 stub, area 172.16.6.0 NSSA. Show IP. Let's see if our neighbor comes up. And our neighbor just came up. This router is a newer iOS version. You can see we got a better log message printed out to the console. Our neighbor state is full. So our neighbor's up. Let's look at our OSPF database. Let's look at our route table. Show IP route. And you can see that our OSPF routes are external type 1. We're learning OSPF external type routes. And we're still learning them from the middle router, not the bottom router. Let's go ahead and look at our OSPF database. Show IP OSPF database. Lots of stuff. Okay, in area 0, we have our area 0. We have our two routers in area 0. In area 0, we have one summary, and this is for the subnet that is in area 172.16.6.0 that the area border router, which we are, the area border router injects that summary route into area 0. And then in area 172.16.6.0, we have two routers in that area, so we have two router LSAs that we expect. And then in area 172.16.6.0, we have two summary LSAs, and these are injected by the area border router, which is the top router, and those are for subnets that are in area 0. And that's all normal stuff. Now we have something new. Type 7, autonomous system external link states. And we get it for These are coming from the advertising router, is the bottom router, 172.16.5.1, and we get 4 of them for each subnet that's redistributed from RIP. And this is what you get when you create a not-so-stubby area. Because OSPF stubby areas ignore external type 5 LSAs, they had to create a new type of LSA, which is a type 7 autonomous system external LSA. So that way the routers would know not to ignore it. And then we have the type 5 autonomous system external LSAs, in which are which in this case are coming from the advertising router 172.16.3.1. Okay, let's we're getting the type 7 autonomous system external LSAs from the bottom router, but we seem to be preferring the external type 1 routes that we're getting from the middle router. So let's go see if we can change that. Here I am in the middle router. Show run pipe begin router OSPF. And it has to think about it for a second because it's a slow router. It's pretty old. And so where you can see we're redistributing RIP metric type 1 subnets. So conf t router OSPF 1 redistribute RIP metric type 1 subnets metric. Let's set a big metric. Let's set up an OSPF cost. Let's see. Let me look back at the costs on. I'm looking way back for costs. Let me set that metric of 1,000. And let's see what that does. Here I am back in the top router. Let's do a show IP route. Okay, so I increased the cost of the routes coming from the middle router, and so because I increased the cost coming from the middle router substantially, the costs of the routes coming from the bottom router are preferred because the bottom router has the normal cost. So before it was external type 1, and now when I do the show IP route, it's still an OSPF route to get to those routes, but instead of an E1, it's an N1. And up in the code, the E1 is OSPF external type 1, which is what the middle router was reintroducing, and the N1 was the OSPF not-so-stubby area external type 1. So that's so our redistribution on the bottom router is working. The bottom router, even though it's a not-so-stubby area, it is not. This area is not so stubby, and so it is not getting the. So the top router, which is an area border router, is not introducing type 4 or type 5 LSAs into the area. And that simplifies our route table, but we can still redistribute from other routing protocols into OSPF on the bottom router, and that becomes a special type 7 LSA. And then what's happening is the top router is taking that type 7 LSA and changing it into a type 5 LSA for all the other areas. So that's a common question on most certification, advanced routing certification exams. What exactly does a area border route, how exactly do the LSAs get propagated in a not so stubby area? And the answer is that the the autonomous system boundary router in the not-so-stubby area, because it cannot introduce a type 5 LSA into the not-so-stubby area, it introduces the new type 7 LSA. And then that type 7 LSA gets changed, converted back into a type 5 LSA, a normal external, by the area border router, and then gets sent off to the other OSPF areas, which are not stubby at all. So one thing about the not-so-stubby area is it's like a stubby area because it still learns summaries from area 0. And we can see that here on the top router, show IP OSPF database. In area 172.16.6.0, we still have the summary network link states. Now, if you remember, when this area was a stub area, we saw the summaries, but when it was a totally stubby area, we did not see the summaries. We just followed the default route back. But now that we're a not-so-stubby area, we are seeing the summaries again. So there is an option to make this a totally stubby area. And to make it a totally stubby area, a totally stubby, not-so-stubby area. And yes, I know this is getting silly. On the top router, we can make area 172.16.6.0, we can make it not-so-stubby, NSSA, but totally stubby. So it's not-so-stubby and totally stubby at the same time. What does that do? Well, the not-so-stubby means that there are no type 4, or type 5 LSAs in the area. But you can have the type 7 special LSA for redistribution within the area. And the totally stubby means that the area border router does not send, in addition to not sending type 5 or type 4 LSAs into the area, it also does not send type 3 summaries into the area. And that configuration to make the not-so-stubby area totally not so stubby, I guess, is only needed on the area border routers. So this is our only area border router. So conft router OSPF1 network 172.16.6.0 NSSA. I'm sorry, I'm not looking for the network command, I'm looking for the area command. Area 172.16.6.0 NSSA no-summary. So no-summary is the way that you make it totally not so stubby. And our neighbor went down and it was forced to reset, but then it came back up. So again, the top router is configured as totally not so stubby, and the bottom router is configured just as not so stubby, but they can still form a neighbor relationship. The effect of the total is that the top router will not introduce any type 3 summaries into the area other than a default route. So let's look at the OSPF database. Show IP OSPF database. And in area 172. So here we are in area 172.16.6.0. We have the 2 router LSAs that we expect. The only summary network that we have is the default. So this is the effect of the total. And then we are getting the type 7 LSAs because this is a not so stubby area and the bottom router is redistributing into this area. And here are type 5 externals, but they're not being propagated into area 172.16.6.0. This is sort of a shared table for the whole router. Let's go ahead and go down to the bottom router to confirm that. Here we are on the bottom router. show IP route. So the routes that we have our connected routes, and we have our RIP routes, and the only route that we're getting via OSPF is the default summary that we're getting from the top router. In addition, if this area was larger, we would have routes within the area, but because this area only has one subnet and we're directly connected to it, we don't see any OSPF routes within the area. Now, even though we're doing all these wacky things with these stubby, not so stubby, totally stubby areas, within an area, everything's unchanged. You still need the complete routing information to route within the area, and you get that via your router LSAs and your network LSAs. Let's look at our OSPF database. And in our OSPF database, we have one area on this router. There are two router areas, as we expect, because there are two routers in this area. We have one and only one summary coming from the top router, and that is the default. And then we introduce 5 routes from RIP that we're redistributing into OSPF on this router. And that's it. This was all very confusing. So let's go ahead and do a review. Stub area routers ignore type 4 and type 5 LSAs. They ignore basically they ignore external routes. They instead just create a default route going back to the area border router. Stub area border routers do not inject type 4 LSAs or type 5 LSAs into a stub area. Stub area autonomous system boundary routers do not inject type 5 external LSAs into the stub area. So that means that stub area autonomous system boundary routers are not useful, at least not within the stub area, because you can't redistribute into a stub area because you can't have external LSAs in a stub area. Totally stubby area border routers go one step further than stub areas. They also, in addition to not injecting type 4 and type 5 LSAs into the area, they also only inject one summary type 3 LSA into the area, which is the default route. And that way they greatly reduce the number of LSAs in the area, greatly improving the area's stability. And a more recent development in OSPF, although more recent means, like 8 years ago now or something like that, we have these not-so-stubby areas, which a not-so-stubby autonomous system boundary router will redistribute routes into the area. Instead of redistributing them in as type 5, they'll redistribute them in as type 7, not-so-stubby area external LSA. And then the area border routers for not-so-stubby areas have the special job of converting the type 7 external LSAs into type 5 for other non-stubby areas. Okay, that's it for today's session on OSPF totally stub areas and not so stubby areas. These are confusing topics, so I do suggest that you read up a bit on this and maybe watch this episode twice, and that's the way to really get it to sink in.